Okay, in this week we're talking about non-renewable energy, and next week then we'll be talking about renewable energy, but we always start out talking about non-renewable because that's what we're primarily using for electricity generation right now. So this week we're going to discuss non-renewable energy sources, the pros and cons of them, how we get them, and you'll have a really good understanding of that hopefully by the end of these videos. So let's start out by talking about energy sources. So as I said, we have non-renewable sources and then we have renewable sources. So this week we're going to focus on talking about fossil fuels. That includes coal, oil, natural gas, and also nuclear power. That's also one that a lot of people often forget, which is a non-renewable energy source. And then next week we'll jump into renewable sources, which a lot of people call green. I don't like to use the term green because they're not always green, as you say, but they are renewable sources, and we're seeing a lot of progress made in that department, especially in solar and in wind. But the renewable sources would include wind, hydropower, geothermal, biomass, solar, and fuel cells. So we're going to talk all about that next week. But again, this week we're primarily focusing on fossil fuels and nuclear. So I want to start out first by going over exactly how do we produce electricity. That's something that you need to understand, especially for the exam. You need to understand how a general power plant works. So what you do is you start out with a fuel source. So in the case of this week, we're talking non-renewable energy. So we're going to be talking mostly coal, oil, natural gas, some kind of fuel source or nuclear power. That fuel source is being used to generate heat in some kind of a large furnace. The heat given off by your fuel source is used to heat up water, which then boils and gives off steam. And the steam then is used to turn a turbine. So you get water boiling, and then you get the steam giving off, which powers a turbine. Okay, the turbine has kind of, you can think of it like a fan. It's got these paddles on it and it starts spinning. Now, attached to that turbine is a generator. And the generator rotates around as the turbine is rotating around. Now, attached to that generator is a very large magnet, and that magnet gets spun right up against a copper wire. And in terms of a power plant, it's a rather large gauge copper wire. And when you take a magnet and you spin it around a copper wire, what you actually end up doing is exciting the electrons in the copper atoms in that wire. And they basically pop off of their atoms and they start to move around. And it's that flow of electrons that is electricity. So we take that movement of electrons and we harness that to power things in our life. That is what we use as electricity. So that electricity then is collected off of the power plant, sent off to the grid, where it is then distributed off to homes, businesses, industries, wherever it needs to go. So the grid is basically how we distribute energy. Okay, so this is basically a schematic of what your typical power plant's going to look like. Number one shows your fuel source coming in here. So this one is showing it's a coal-fired power plant. So you have coal coming in, that's your fuel source, and it basically goes into this bunker where it's pulverized. They oftentimes will grind it up because it can burn faster and hotter, and you get a lot more energy and you can keep it moving. So it goes into this bunker, it gets pulverized, ground up, and then it gets sent down into the furnace where it is ignited. So the furnace, you're creating a lot of heat there. And you'll see these pipes up at the top, and those pipes contain water. So those pipes go into the furnace, the water within those pipes begins to boil, and as it boils, those bubbles of steam make their way up and get into this turbine area. And the turbine then is spun around by this steam coming up into there. So the turbine spins, and then the generator you see there is attached along with the turbine. So the magnet inside the generator also spins, and that generator has that copper wire in there. And so then you get that electron movement, which is electricity. And then that electricity is captured and sent off to the grid. Now, as the steam comes through the turbine, it starts to cool down and it gets sent down into a condenser. And what that's doing is it's basically a cooling loop. It's taking that steam, it's sending it into this really large cooling tower where it goes through this series of pipes that are run cold water over them, cool down. The steam condenses back down into water, and then it's sent back through the system again to boil up again, turn into steam, power the turbine, so on and so forth. Now at the bottom, you'll see that there is a waste product, okay? When you burn most any fuel source, you're going to have a waste product. In the case of coal, we get ash. Just like if you were to burn wood in, say, a bonfire or your wood stove at home, you have a residue of ash left over. Well, you have to do something with that waste. So they take the ash that's not only airborne, but whatever comes out of the bottom of the furnace there, they put it into a giant truck or a railway car, and they take that ash and they ship it off to a landfill and dump it out there. So that's some of the problems that you have is what do you do with all the waste? But that's the kind of inner workings of a general power plant. And it works the same way whether you're using oftentimes a renewable energy source versus a non-renewable. You're basically taking water and heating it up enough to create steam to power the turbine to spin the generator to create electricity. So you need to have some basic understandings of how that works. All right, and this is kind of a schematic of what the power grid looks like, so we call it. Okay, you've got your power plant up on the upper right there. It creates the electricity. You've got your transmission substation, which is sending that electricity off to the major high voltage transmission lines. Those go off to your local power substation within your different neighborhoods. So if any of you drive Monterey there, you drive right past a power substation, kind of just to the south of Hoveley. It's off to the right-hand side as you're traveling south. That is a power substation. It's taking that really high voltage electricity and it's transforming it into a form of energy that goes to your house, your small businesses, along smaller power poles. It has to go through a transformer drum and then it can enter your house and use to power your lights, your stove, your microwave, anything in your house, your computer, anything that you're using in your house. So that's what the power grid looks like. So what are the primary sources of energy in the United States? What do we mostly use? Well, unfortunately, we rely very heavily on these non-renewable energy sources. So a lot of coal, a lot of oil, a lot of natural gas. And this is not unique to the US. Most of the world relies very heavily on non-renewable energy sources. Again, what as I just said, includes coal, oil, natural gas. And then we also have some production from nuclear energy, and we're going to go over nuclear energy in further videos. Now, our biggest energy consumption, what we use most energy for, is for our transportation and for industry. Okay, so you're putting gas in your car probably a couple times a week, depending on how far you drive. If you drive as far as I do, unfortunately, it's more often. If you don't drive far, then it's not too often. But transportation is a huge energy consumption part. And then we also have industry, all the production that we have going on around the world that consumes a lot of energy as well. Now, approximately 50% of the energy in the United States that we use to produce energy through our power plants comes from coal-fired power plants. And that's still true today. We do have some major steps being taken in solar energy, as you probably see, especially here in the valley, but we still rely quite heavily on coal-fired power plants. Much more so over on the East Coast than over on the West Coast. Over here, we actually use a lot of hydroelectric. We're going to talk about that next week. So, what are fossil fuels? How are they formed? Well, just as their name implies, they are basically fossils that are turned into a fuel source. So you have organic, remember organic means kind of living matter, anything containing a carbon-hydrogen bond that's useful to living beings. A lot of times it's small little dead plants and little animals, and usually it's marine based. We're talking a lot of algae, zooplankton, phytoplankton. The reason for that is that fossil fuels are formed in an anaerobic environment, and you usually get that type of an environment. Anaerobic means no oxygen. You usually get that type of an environment underwater. So oftentimes in swamps, at the very bottoms of oceans where you're not getting a lot of oxygen going in there. So what happens is these organisms die, they sink down to the bottom, and they find this anaerobic environment with little to no oxygen, which means that the bacteria that should be going through decomposition and breaking all that down are not in that area because there isn't any oxygen for them to take over that process of decomposition. So there is very little decomposition, which means that they're preserved. Hence, you have fossil in the name fossil fuels. And then they get sediment on top of them, and the heat from the earth, different temperatures and different pressures fossilize and create different fossil fuels. Now, I put up a link to a video in your PowerPoint lecture, so definitely watch that because it's a nice little overview of how fossil fuels are formed and how we get the different fossil fuels. So here you see coal, you've got oil, and you've got natural gas. So coal basically is more your woody matter, your plants that are compressed down. It's basically that more woody material. And so it turns into this type of rock-like substance that we take and burn. Oil, on the other hand, tends to come more from algae, little animals, more slimy stuff. And it depends on the temperature and the pressures that it's cooked at. Natural gas results from coal and oil breaking down and being cooked, and you get these pockets on top of your coal and oil deposits. And natural gas is primarily made up of methane. So that kind of comes about after the process has taken place, and it's basically a byproduct of these fossil fuels continuing to be cooked in the earth. Now, if we look at a time scale over the history of the Earth, most people think fossil fuels, because of the name fossil in there, they come from the time when dinosaurs were on Earth, which is the Triassic, the Jurassic, and the Cretaceous periods, that Mesozoic time, that era. However, most of our fossil fuels actually formed during the Carboniferous period, which is in the Paleozoic time, anywhere from about 350 million years ago to about 300 million years ago. And this time is before most of our reptiles, excuse me, most of our dinosaurs were on Earth. So a lot of people are kind of surprised to find that out. And then this is basically a pie chart that the EPA collected data in 2005. So it's a little dated, but it really honestly hasn't changed all that much. And it's showing us the different fuel sources that we use to create electricity in the United States. So you can see that nearly half of this pie chart is in black, and that is the coal area. That's all the electricity almost half of our electricity in the United States comes from coal-fired power plants. Now, the other two big players here, the red chunk there, the red piece of pie, that is our nuclear power plant production. So we do have quite a bit of nuclear going into it, almost 20%. And the other large player is gas. That would be natural gas. So we have been using natural gas for a while, and we're seeing more natural gas. And we're going to see why we use more of that. But that's the yellow piece of pie there. Now, the small gray slice is oil. Okay, we think of using a lot of oil, and we do use a lot of oil, but not so much for electricity generation as much as for transportation for our cars. So this is just showing electricity generation in the US. So that's why oil is a small percentage. Some homes still they have an oil furnace. So you have a truck come to your house, they fill up your oil reservoir, and then that feeds in, and it's an oil production, and it heats your home. Now, the blue, the greens, and even the pink and all that, that's kind of our renewable section. So that little chunk over there, which is about 15% or so, we're going to talk about that next week. That's all our renewable energy sources. Okay, that's the end of this video. In the next few videos, we're going to go over the different fossil fuel sources, how we use them to create electricity, the pros and cons to them, and then we're going to finish up talking with nuclear power, and then we'll go over some energy conservation. So that's kind of what we're going to talk about this week.